block of mass 5 kilograms is initially moving with a speed of 14 meters per second at point A as it travels on the frictionless path A to B shown in the diagram. Upon reaching point B, the block begins to move up a rough inclined plane, B to C, which makes an angle of 15 degrees to the horizontal. The coefficient of kinetic friction between the block and the incline is 0.42. The block comes to a complete stop precisely at point C. Write down the magnitude of the velocity of the block at point B. Now, from A to B, there's no friction. Let me use this color. So right here, we don't have any friction. And we don't have any applied forces. So we don't have forces that are trying to speed up the block, and we don't have forces that are trying to slow it down. So which means the velocity will remain constant. Newton's first law. So at B, we will still have the 14 meters per second, the initial velocity at A. So Newton's second law states that basically an object will keep moving at uniform motion or remain at rest until acted upon by a non-zero resultant force. We don't have that here. We don't have a non-zero resultant force, hence it will keep moving at uniform motion, in this case 14 meters per second. Now, part B, calculate the frictional force as the block moves from point B to point C. Now we can draw a nice little sketch over there. Just make a nice little diagram there. Now that's going to be 15 degrees right there, and this being FG, let's make it a bit clearer. So this hypotenuse side there will be FG, and this right here will make that the FG perpendicular. It's perpendicular to the surface, and then this is FG parallel, since it's parallel to the surface. Now this is the FG we're interested in, because if we draw our free body diagram, this is FG and that is Fn. Now, you see, when FG is broken up into its components like that, this component here is acting in the same axis as Fn. So they are the only two forces that are acting in that axis. So since I'm interested in those forces, I will just, the block is not accelerating up, like just taking off from the incline. So we will say that our forces in the y are equal to 0. There's no acceleration in that axis. And what are those forces in the y? It's basically the normal force plus the negative FG parallel, let's give us 0. Now when I take the FG parallel to the other side, it becomes positive. So normal force is equal to the FG perpendicular, sorry, I didn't mean parallel, perpendicular. Now I need to know how to find that FG. So when we look at that triangle, so this being FG, now what is FG? It's mg, right? It's mass times acceleration due to gravity, and then that is our theta right there. So to find this side, it's cos theta. So cos theta is equals to adjacent, which is the FG perpendicular, the hypotenuse of mg, cross multiply. Therefore I have that FG perpendicular is equals to mg cos theta. Now I could go ahead and get the exact number or you can just use, or for now we can just use this thing as it is on our formula for frictional force. Okay, so now this gives us 5 times 9.8 times cos 15. That gives us 47.33 newtons. And now when I calculate frictional force, Fk is equals to the coefficient of kinetic friction times the normal force. So 0.42 times 47.33. That gives us 19.88. Yeah. Now this is down the slope. Now the last question asks for determine the length L of the incline BC. So we'd like to know what is this length. Okay, so the block moves from B to C, which stops at C. Now as it moves from B to C, it experiences a frictional force. Now we have a non-conservative force acting on the object. That's basically a force that's either trying to speed up or slow down the object. So in this case, it's only frictional force that we have. So this question can be done using Newton's laws and equations of motion, but we are not going to use that. We're going to use energy principles. Reason being, when it comes to work, power, and energy, that section there, they do want you to use energy principles to answer some of these questions. So we have no choice but to use it. Now, I did not specify this here, but on the exam, they normally do. They do specify that you use energy principles. So we are trying to find distance BC. So how far does the block go until it comes to a complete stop? Since when it gets to B, right, from A to B, nothing is slowing it down. So it's going to keep moving at 14 meters per second. But as it moves from B to C, two forces are going to basically cause it to stop. It's going to be the frictional force and it's going to be the force of gravity, this component there. But that's not a non-conservative force, so we won't consider it here. Instead, we're just going to focus on the frictional force as the non-conservative force. So as it moves from point B to C, now we don't know where point C is. But we're saying that, let's say point C is the point at which the block actually comes to a stop. Right, so we need to know how far the block must travel before it comes to a complete stop. Okay, so since we have frictional force as one of our, basically the only non-conservative force acting on this object, we'll say work done by non-conservative force is equals to the change in kinetic energy plus the change in potential energy. Now we need to break this up. Now we'll start with EK. So we know that kinetic energy is 1/2 mv squared, which means change in kinetic energy is basically the final minus initial. So it's going to be half mv squared final minus half mv squared initial. Now same thing with potential energy. If it's changed, then it's going to be mgh final minus mgh initial. Okay, so that's what we're going to be writing down on the right hand side. Now, what about the left hand side? On the left hand side, we're saying that we are finding the work done by the non-conservative force. Now, how do we calculate work done by a single force? Work done by any force is just that force times the distance the block travels or the object travels while the force is acting on the object. Okay, so since we have frictional force as the only non-conservative force, so work done by non-conservative force is actually frictional force times the distance the object moves while friction is acting on it. And what is that distance that the block moves while friction is acting on it? It's the distance BC. Okay, which in this case we labeled it L. Okay, so on the left hand side we're going to say our work done by non-conservative force is basically frictional force, Fk times L. Right, so it's the frictional force times the distance the block travels while frictional force is acting on it is equals to 1 over 2 mv squared. Now that's point, the final is point C, so I'll use C and B for final initial. Sorry, that's C minus 1 over 2 mv squared B plus mgh at C minus mgh B. Now that we have this, we can just substitute all our values. So our frictional force we calculated to be 19,88. But remember, frictional force is acting down the slope, while our displacement will be up the slope. So these are in opposite directions. Okay, so since they're opposite directions, then the frictional force will let that be negative. We'll choose positive, basically up the slope as positive. Therefore, down the slope will be negative. So negative 19,88 times L, so I'll just say L, equals 1 over 2 times 5, that's our mass, times the velocity squared at C. Now, it comes to a stop at C, so the velocity is 0. That's 1 over 2 times 5 times the velocity at B, which is 14 meters per second. Then now plus the mass 5 times 9,8 times the height at C, which we don't know what it is, minus 5 times 9,8 times the height at B, which is 0. Okay, so now we can just rewrite this, just make it simplified, make it a little cleaner. So that goes to 0 and that goes to 0. So we only have negative 490. That gives us 490 right there. And then 5 times 9,8 gives us 49 HC. Now, you see I have two unknowns here. Now, is it possible to represent L, basically to write L in terms of H, or to write H in terms of L? Yes, it's possible, because remember, we're going up a slope. And this is our theta, 15 degrees. And the height at C, which is unknown, that's the H at C right there. And then this is basically the hypotenuse here, that is L. Now, if I want to have my equation in terms of L, I'm going to solve for HC using the fact that sine 15 is equals to HC over L. Sine 15 is equals to the opposite over the hypotenuse, which is L. Therefore, HC is equals to L sine 15. Now, let's substitute this over there. So negative 19,88 L equals negative 490 plus 49 L sine 15 degrees. Now I can bring this side and go and add it there, and I can take this to the other side and it will change to positive. 490 equals 19,88 L plus 49 sine 15 L. Now we are going to add these. These are like terms, so I can just add them, and when I add them I will get 490 equals 32,56 L. Therefore, when I divide by 32.56, I get that L is equals to 15.1 meters.